Hi everyone, my name is Anav. This is a project I did when I was part of Monash GPU, which is a student team in Monash, which specializes in AI and high performance computing projects. We built a fluid simulation model from scratch using pure C++ and a very lightweight graphics library called SFML, which makes it very optimized and optimized at the very low level. And our approach was inspired by Josh Stam's real fluid dynamics research, and I'm going to show you how it works using a simple demonstration. So imagine this is a box view. You're viewing it from the top, and you add a source like fluid. You're dropping fluids into it, and then you can also manipulate the fluids. Like you can move around your fingers. Imagine you're moving around your fingers and moving the liquids away, and also you can add some velocity to the fluid. So let's say you push, let's say, a glass of ink, and then you add some velocity to it. So when you add some velocity to it, it acts naturally, and it follows the physics of the fluid mechanics. To do this, we can jump into the research paper. So initially this is where we start with our base fluid, in our case some initial smoke distribution, and then we add some forces, like when we add the density, external forces, like, so it simulates external forces like wind or pushing the liquid around, and then we have to smooth out the density while moving it. This allows the ink to spread out evenly, and then advect or like move, where we have to move the liquid along its velocity field, which gives it a realistic swirling motion. So how we achieved that was, so let's say when we move it, it's very realistic in the way it moves around. And another thing, we added some other views as well to visualize the fluid. And here are the vectors. So you can see, like, when I add something and move it this way, the arrows are pointing that way. So let's say I'm giving it direction. So the arrows, this is like basically showing the vector fields and how the fluid interacts with the forces. So now I would like to focus on an interesting part of the code, which is the advect function, which allows the smoothing of the diffusion. So every cell we have, okay, I'll just close this for now. It was logging. So over here we have, for every cell, we compute a new position looking backwards along the velocity vectors. Imagine you're trying to figure out where the puff of smoke or the ink came from, like in the previous moment in time, and then we figure out the interpolation, and based on that we find the 4 neighboring cells of that cell, and we find the interpolation from the fractional paths of our traced coordinates, and we ensure that the movement is smooth, and this computes the interpolation and smoothens it out with this macro. So this thing basically ensures that whatever force we apply, the diffusion is smooth according to the math. And now to show the research paper, so this is what we use. So Josh Stam, a shout out to Josh Stam for making this brilliant paper, so that which helped us build this model. And these are the things that I just explained right now. And we use his code and explanations to build a thing. And by combining these resources, we created a continuous realistic simulation, and the entire system is built in pure C++. So it avoids any extra overhead of like full game engines or other libraries, so making it super lightweight, and it can also run very fast on the modest hardware, like low-end computers. Thank you very much for watching the demo.